Hi guys, this time I've done something very different. So Clement does these Google mock interviews on his channel and he's interviewed some amazing people. So I thought why not give it a try. And we did two interviews. One is on his channel and one is here. I did a little bit better in the other one. But on the brighter side, after this entire interview, we had a really nice, healthy discussion of the mistakes I could have avoided, things I could have done better. So I hope you will get to learn a lot from the entire experience. Clement is this amazing person who is ex-Google engineer, ex-Facebook engineer, and I'm sure you know he is now the CEO of Algoexpert. So before we get started with the interview, let me tell you a bit about Algoexpert. If you go to content, you will be able to see coding interview questions. There's a crash course on data structures. There are interview assessments and of course mock coding interviews. If you're preparing for system design interviews, then there are some videos on fundamentals, there are questions, there is quiz available. And of course, there are videos on all of these topics. And if you want to practice questions, there are questions available which you can sort by category or by difficulty level and you can practice. So this is the ultimate guide. To check it out. It might just be the thing that you're looking for. And as a giveaway, you can use the promo code Kirti to get an additional discount while using the platform. So here's the link that you can use for that.
What's up, everybody? How's it going? So thank you for the introduction. Kirti, as she said, I run Algoexpert. I have my YouTube channel. I used to work at Google and Facebook. We did another Google coding interview, mock Google coding interview on my channel, and ready to do the second one. You are going to be given two input strings. One of them you can think of as a big string and one of them as a small string. So the small string is always going to be smaller than the big string in length. And you have to return the number, or write a function rather, that returns the number of permutations of the small string that are found in the big string. So I'll give you a sample input and then give you a few, sort of constraints. So you could imagine that you might have as a big string equals this, right? And then small string equals, let's say, ABC, okay? And the answer would be 6 here, and the various permutations of the small string that are found in the big string are these. And you can see that some of them, like ABC, are repeated. So you have ABC right here. You have ABC right here, right? So you have two instances of ABC. And ABC happens to also be the exact small string, but it counts as a permutation of itself. And that's that.
Okay. So bigger one will always be greater than the smaller one, right, in length?
Yeah.
Okay, so at the top of my head, what I can think of is that we can use sort of a sliding window of length of the size of the smaller string. So in this case, if it is 3, right? So as I move, like if I have this window right now, the first time it will be CBA, right? So I will have a map of the counter of the alphabets that are there in the smaller string, as in the number of alphabets, like here A is 1, B is 1 and C is 1. So when I am at a particular window, I will see that the counter of all the alphabets is same for this window string as well as for the small string. If it is same, then it is the permutation, otherwise it is not the permutation. Does that make sense?
Yep. And how would you actually count the characters or the letters?
Yeah, so that is the tricky part over here. So actually, there are multiple ways in which I can do it. One is that will these characters be always small characters? So can I assume that there will be 26 characters, or they can be caps and special characters as well?
Let's assume that they can be any sort of normal characters that you might have on a keyboard. So it could be uppercase, lowercase, exclamation points, but they're all of length 1. You can treat them as not super fancy characters, and they're all, let's say, like ASCII characters.
Okay. So instead of keeping a vector, it is better to keep a map because it can be any special character, right? So I will keep basically my map will be sort of like this. So character and the counter, which will be integer. So this will show the number of characters that are coming, right? Number of times that particular character is coming. So like when I go for, so first I will iterate this small string and fill this map. So A is 1, B is 1, C is 1. That is how our map will look. Okay. Then I will start iterating through my window, and then as I go through each character, I will keep checking that that if as I go through a particular character in the big string, I will add the counter in a different map. So there will be I will have to keep two maps then, and then I will have to compare the maps. So I am thinking whether do we really need two maps or is one map enough?
What do you think?
So one map to at least we will need for the small string. For the big string, if I think we will end up needing two maps, and I will keep increasing the counter. So if at any time the counter will be more than the counter corresponding to that character in the first map, then I can just return false, like I can just move my window to the next part because it is not there. But I'm thinking, is it some way possible to not use the extra map and just use one map? Or do you expect me to make it better, or is it okay if I use two maps?
Well, is there a reason that you would prefer using one map over two maps, or no?
It's just some space optimization, right? That instead of using two maps, I'm using one map. So it's just a little bit of optimization. So the space will be essentially same. So order of number of characters, but instead of keeping two maps, I'll end up keeping one map. Or is it okay if I keep two maps?
I think two maps is okay because, I think you hinted at it. The space, in the grand scheme of things, the space complexity won't be affected by having two maps because the two maps will be of the same order.
Yes, exactly. So
at least, yeah.
Yeah, please go on.
I was going to say just at least depending on if you store the same characters in one map as the map of the smaller string, but I think two maps is fine. I don't think we need to try to look for only one map.
Okay. Then yeah, this should be fine. Now I'm thinking, so once I have filled both the maps, so one is that anytime the number of characters become more than the first map, I know that this is not valid. But in every window, instead of checking for all the characters again and again, like instead of comparing the two entire maps, I think we can do better, because when I shift my window, I will be adding one character and removing one character, right? So if I can just check for those two characters instead of going through the entire window, to the entire map, maybe I can make it somewhat better. Am I able to make sense? Like, am I able to communicate what I'm trying to say?
Yeah, and just walk me through, maybe if you want, with this example, walk me through how exactly you would do what you just said.
Okay, so when I go through my small string, after that, this is how my map will look. It will be like A1, B1 and C1. So this is how my map looks right now. Okay, so I start iterating through my first window. So when I go through my first window, so this is suppose my second map. Okay, so this is like where I am writing. So here I increase the value to 1. So if suppose this counter would have become 2, so that means the number of characters are more than the number of characters that are supposed to be there. In that case, I will anyway move the window. I know it is not true. Okay, so then in the next case, so again, now I come to B. I will increase my counter to 1. Then I will increase my counter to 1. right? So here in this case, I know that it is true. So when now because the counter is exactly same, the maps are exactly same. Now when I move the window, I can just remove this character and add the new character and check, right? But if
And so just, sorry to cut you off, Kirti, but just here, obviously you and I can tell that this is true because 1 1 1 1 1 1, but how in the code would you determine that this is true, that this is a correct permutation?
So that's what I was saying, that at least the first time we will have to go through the entire map, I think.
Okay, so you would go through the entire map.
And I see whether the counters are same, then it is the permutation.
Okay, sure. Okay, so then now you move on to the next thing.
Yes, now there are two possibilities, whether it was the permutation or it was not the permutation. If it was the permutation, then it is very easy because I just have to decrement this one. So I just have to compare the counters for the character that I'm removing and for the character that I'm adding.
Right, yes.
But if it was not the permutation, then it becomes complex. Like if my big string was DEF, then again when I go through the next three characters, which could have been CBA, then I will again have to go through the entire map, right?
So here in this instance, you would go through the entire map, both for DEF and for CBA, and even maybe like in between, like EFC.
Yes, but I would not go through the entire map for the second one, but just the first one, not the second one, because that will be of smaller size always, right? Because the smaller number of characters in the first one.
Right. Do you think that there's a way that you could avoid having to go through the entire map at all, like entirely?
Like not even the first time?
Yeah, not even the first time.
Okay. One thing maybe I can do is, okay, maybe if I keep a counter of the number of alphabets which have same counter in the so the number of alphabets which have the same counter for both the maps. Okay, now suppose I am at D. So right now I know this counter will be 3 when I go through all this small substrings. So for something to be permutation, like there are supposed to be 3, the counter is supposed to be 3. But if my counter is greater than 3 or less than 3, then it is not a permutation. So this counter will tell how many characters are there which have same number as the previous map. Does that make sense?
Yep.
So yeah, I can use that counter and I wouldn't have to go through the map again and again.
And so maybe just re-walk me through that first example of how you would increment or decrement that counter.
Yes. So now when I go through this, so now when I come to C, I increment this and this becomes equal, right? So now when this becomes equal, I will make this as 1. My counter becomes 1. Then I come across B and I increment this, and then I see, okay, after incrementing again, the counter became equal. The values became equal for both the maps. So I increment the counter to 2. Similarly, for this one also I increment and I see that, okay, this is 3. Now I am done with my entire window and I check that, okay, this counter is same as the number of characters that are actually there in the string, in the smaller string. So so there are that number of characters that have same number of occurrences. So it must be a permutation.
Okay, and then what happens just at the next character?
So now when I go through the next character, right now I was at CBA. Now when I move my window to BAB, right? So now this time I remove this C, right? So I will first see if it was same, if the number of characters was same, then before removing I will decrement the this counter, and I will also change this value, and then I will add b. So I will increment this counter and I will see, is this equal? If it is equal, then I will increment it, otherwise I will not increment this counter.
Right. Okay. And so here you would see that it's 2, it's not 3, and so okay.
Makes sense?
Okay, so I think this seems to make sense. Maybe we can write out the code and we can talk about the complexity analysis after the code.
Okay. So I will write a function that takes two strings, big string and small string, and I return an integer.
Yes, an integer.
Okay. So that will be the number of permutations. So integer, what do you want me to call the function?
You tell me. Or I guess for this I can tell you the function signature I had in mind. Because you can go with permutations contained in string.
Okay. Oh, sorry, I misspelled it.
And don't worry about like the capitalizations or things like that, or like the Google Docs auto formatting.
So one is big string and one is small string. So this first I have to go through. So can I assume that there will be at least one character, or otherwise like I should just return 0 if both are empty? Or
let's actually assume that they're both non-empty. So the two things that you are guaranteed, like you don't even have to worry about it, is that they are both non-empty and big string is always bigger than small string.
Okay. So then I can just make two maps. So I am making an ordered map of a character and an integer. So this is for small string char count.
Okay.
I'm using big names, but it is going to be really painful to use them. Okay, big string character count. Okay, then first I have to fill this first one. So for that I have to go through the small string and fill this map. So I can just use it like this. For character C in the small string. So this is just a way to write in C++. Instead of writing the entire I equal to 0, I'm just starting it like this. So
Yep.
In C, I'm just adding it, right? So initially it will be 0. So by default it is 0. And for this particular character, I've just increased the counter. Make sense?
Okay, and just to be clear, in C or C++, it does have a default value to 0?
Yeah, it does.
Okay. Because like in some languages, this would error out if you don't check.
Yes, but in C++, the default value is 0, right? And I will keep the length also somewhere, because I will have to keep comparing my counter to this length, right? Sorry.
Okay.
So small string length. So this is just to compare the length, and I will also make my counter to 0. Make sense?
Okay.
Is it okay if I call my counter as counter, or you want me to name that also better?
I mean, what would you do in a production code base?
Yeah, I wouldn't name it counter for sure. I would call it, okay, it takes me some time to think of the name. So probably counter for, what to call it. So this basically tells the number of characters. Can I just call it counter right now?
You can call it counter right now. Naming is hard. I know naming is hard, but yes, here this is the counter that keep tracks of how many characters are matching counts in small strings and big strings. Yes. This is actually one of those like very difficult to name variables. But yes, okay. In production, you would name it differently, but here for velocity, you can name it counter.
Yes, thank you so much. Right, okay. So now I have to first fill my first window, right? So for so my window will always be of the length L, right? And I plus plus. So I will just see if I can reuse this code like for the first window and for the rest of the windows. Right now I'm just writing it for the first window. So
okay,
when this happens, okay, so the first time I just have to add, I don't have to take care of the removing of the previous one, right? So now so this is my big string. So in my big string character count, this is my map. In this, I take the character at I and I increase the counter.
Okay.
So after increasing the counter, I check if this one is, so if this is equal to, so in my small character count, there would have been the counter for this exact same character, right?
Yeah.
So I will check if both the values are same, then I will increase my counter. I should also check, okay, no, it can't be possible that it was already same, right? No, it is not possible. So I'll just increment the counter if both the values become same. Does that make sense? Yeah, so this is all I have to do when I am going through for the first time, right? Now comes the times when I have to slide my window. So for that, right now I'm writing a separate for loop. We will see if we can make this as common reusable code, since it is going to be used. Now I have to move my window to the next characters, right? So I go from int I equal to L, and I should be less than or equal to n minus L. So when my I will become equal, so when my this is basically the last case. So suppose my length is 10 and my suppose my length is 5, and that is the number of the characters is 5, that is 0, 1, 2, 3, 4, and my window size is say 2, right? So I want my I value to go till 3, which is basically equal to 5 minus 2, which is n minus L. That is why I less than or equal to n minus L, right? Then I plus plus. So it makes sense till now? So so now when I am moving the character, so this part will remain same. This is when I am adding it. Well, now what I have to do is I have to remove the character also in the previous one, right? So what I do is, okay, I haven't taken care of a resultant value that I have to return, that I'll just do that later. So first what I'm doing is I'm going to remove the character. So for that, I am at I presently, so I have to remove the one at I minus 1, because, no, 1 second, I have to add, so my I is at, so this is 0, 1, 2, I move to BAB, so now my I is this, so I have to add, I have to remove the I1 now, so this I will become minus minus, but I have to add the next one. So since so it will be like 0, 1, 2, 3, so it will be I plus L. Sorry. Right. So and here also it will become I plus L in both the cases. So I'll be adding the right one and removing the left one. Make sense?
Can you re-walk me through that?
So I'm here right now, right? Now so here my I value was 0. Now when I move it to BAB, my I value is 1, right? but my L value is 3, right? So which one am I adding? I am adding this B. So this one is at 0, 1, 2, 3, right? So, okay, I have to do minus 1, sorry, that is a stupid mistake.
But L, what is L?
L is this small string length, so our window length.
Okay.
This is our window length, right?
Yeah.
So now it looks fine?
Yeah, I see.
Yeah, okay. So
your I plus L minus 1 is your rightmost window pointer.
yes, so I am adding the new character at I plus L minus 1 and I am removing the one at I.
Gotcha.
Right? So
Yep.
actually I have made a mistake here. Instead, so because I'm starting from I equal to L, no, so I should start from I equal to 0 itself and less than or yeah, now it's fine.
Okay.
Because I'm removing at I am adding at I plus L minus 1, so I take from 0 to N minus L.
Okay.
Right. So now when I have decreased the counter, so first I have to check if it was earlier equal. So that will have to be done before decrementing the counter. So if these were equal, what I do is I decrement the counter. Make sense?
Yep.
So if both were equal, I have decremented the counter and I have reduced the number from the map as well. So, right now I have to keep, so in every window I have to check that if my counter, so this is for my first window, right? So if my counter is equal to length, then I have to do a resultant plus plus. So my initially resultant is 0, right? And I have to add the value. So this is the value that I am going to return, right? So the first time when I am there, so from int I equal to 0, this is the first time that I am over there. Now I will keep adding, so I have to put this check over here also. Yeah, this should work fine. Should I dry run it for the example?
Should you what?
Should I dry run for the example, like walk through the example with the code, or?
You can walk through the example as soon as you have finished the function. Do you think that it's done right now?
Yeah, it is, I think.
Okay, so then let's do a dry run then.
Yeah, it's done, right? Yeah, I think so. Yeah. Okay, so we'll start from here. So right now, here this much is fine, right? I have just added all the values and I have made this map like the first.
Yep.
Right? So these values are not there. I have just added it. Okay. Now, so this much is done. Now I come here. So my length is equal to 3 and my counter is 0. Now I start from, so this is the first time I am going to the window, which is this CBA. Now for each, so 0, 1, 2, and for each of them I just add the map value, so it will become 1, 1 and 1, and for each of them I will check if the counter, if both are equal, so it will happen. I will keep on increasing the counter, right? And I will also check, is my counter equal to my length value, which is 3, then I will add the result. So it was not there initially. Actually, instead of adding it over, instead of checking it in the for loop, I can just check it outside the for loop, because I just have to check if this the first window is the answer or not, essentially. So I don't need to check again and again. Okay, so here right now our RES is 1 and our counter is 3, which is correct, right?
Yep.
Now when I come over here, my I value is 0 and it will go till n minus L. So n value over here is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it is 10, so it will go till 9. 9 minus 3, which is 6. So it will go till 6.
Okay.
Okay. So now I add for I plus L minus 1, which is 0 plus 3 minus 1, which is 2. 0, 1, 2. Actually, initially I had done it right.
Without the minus 1.
Yeah. Sorry. So now it's right because I changed the I value, right? So if it is 0, it is now 0 plus 3, right? So I am adding the third one. So this is, and I am removing the ith one and I am adding 0, 1, 2, 3. I am adding the third one. Makes sense? So I plus L, so when I value is 0, this is I plus L is 3. So I end up adding B. So I end up increasing this counter. So now this counter is not same. So I increment the counter. Actually, I should decrement the counter not just for this one but also for B, right? Does that make sense? So
because it's bigger.
No, because I am incrementing the counter, right? So I am no, I don't have to do that. The counter can be bigger, it doesn't matter, right?
Well, here you're not incrementing it because you only increment it when it's equal.
So I'm saying that it was equal for B earlier, right?
Yeah.
Now I have added this and now these two are not equal.
Yeah.
Right? So if it was something like this, if it was say BCAB, right? Then after adding it, it will become, I'm just thinking like I am decrementing the counter if it is not equal for the left pointer, right? I am thinking should I decrement it even if it was earlier equal to for I plus L or not?
And so what do you think? Like if you walk through an example.
So okay, just give me a second. When I am basically I am removing a character from here and I am adding the character over here, right? Now when I add the character, I am increasing the counter. If the counter was earlier equal and I end up increasing it, it is still okay, right? Because the rest of the counters will not be equal. So I will not end up increasing. So I think it's fine. It's fine if it is like this. Yeah, it's fine.
Yeah.
So I'll just,
and because the length of the window is always the length of the small string.
Yes.
Like it will counterbalance itself later when you decrement stuff with the left pointer.
Yes, exactly. Yeah. So I have added the B1 and now I have to decrement. So I will check was it equal for C? Yes, it was equal. So I decrement the counter to 2. And then after that I reduce this counter value, this map value to 0. And now I check is counter equal to length, then I will increase the resultant value, otherwise I won't. Do you want me to walk through the entire thing or is this much enough?
Let's just do a couple more. But so right now at this point the counter is 2, right? You said?
Yes.
So this would not get like hit. Okay.
Yeah, so I went through CBA, then I went through BAB. Now I again go to ABC. So my I value is now 2. So now when I value is 2, 2 plus 3 is 5. So I'm basically at this C now. So now I increase the counter value of C, which is 1. Now since these two became equal, I am going to increase my counter to 3 and I will check for I. I was what? I was A over here because I'm at ABC, right? So
Yeah.
I end up reducing, so one second. I will check if it was equal. Yes, it was equal. So I will again reduce my counter to 2 and I will, one second.
I was not at 2. I was at 1.
I was at 1, right? I was at 1, sorry. So this will be 3. I messed up somewhere. So this will become 1 and now since they were not equal, yeah, I was at 1 and now I will, I have decremented the counter and now I will check if this is equal, so I will increment this ABC, so I will have another answer.
Yep, exactly.
Yeah. So now my I value will become 2.
Yep.
Yeah. Now when now I am at A, I will remove A first. So now when, okay, let's add the first one because it's written like that. So 0, 1, 2. So now I add A, this A
Yep.
I am adding. So I increase the counter and after that I check was it equal earlier. That means was 1 and 2 equal? No, it was not equal.
Yeah.
So I don't decrement the counter.
You don't increment the counter. Yeah.
Yeah. Now
you don't increment it.
Yeah. Now I have to remove this A, the first one, and I decrement it again, and my counter becomes equal again. So this is another answer, which is BC.
Okay. I think we can probably stop. But yeah, and so here at this point, you would so far have counted 3, right? CBA, ABC, and BCA.
Yes.
And it would go on like this.
Yes.
Okay, so cool. Let's do 2 things. The first one is, can you walk me through the complexity analysis of your solution?
Yes. So this part is order of the length of the small string, which is L. So this is also order of L, this is also order of L, and this is order of N, which is the big string length. So it is actually order of N plus M, which is the number of characters in both the strings. And and space complexity is order of N plus M again. So order of N for the bigger one and order of M for the smaller one.
Say again, what variables are you using?
So if
Can you write out the variables?
If N is the number of characters in the like the string length of the first big string and M is the string length of the second string, then so order of N for one map and order of M for the second map, so order of N plus M space complexity.
But isn't this map are you you are adding characters from the big string. You're adding every character from the big string.
I will end up adding all the characters, not just the small ones. So the length of those 2 maps will not be equal. So the small one will have only the characters in the small string and the big ones will have some other characters as well, which will be there in big string only. So it will be order of N plus order of M.
Do you need to add the big string characters? Like the ones that are not in the small string, do you need to store those?
Actually, no, I could have saved space like that. So I could have added the check over here that if my, that is in small string count. So in this map, if big string of I plus L is, so I should have added in both the places, in the first window as well as over here. So only if it is not equal to 0, like if or else I can use the find function to check if it reaches the end value. If that is the case, only then I add and I do all of this. Otherwise, there's no need of doing it. Then
Yeah.
I end up saving the space.
And just to be clear again, in C++, if you check,
Not equal.
it would always be equal to 0 if it's a character that's not there.
Yes. Yeah, I could have actually. So yeah, it might not work in some languages and in some compilers. So yeah, I could have written like map.find if it is not equal to map.end. Then yeah.
Okay, that's fine.
Yeah.
That's fine. Yeah. And so just what did you move exactly? You moved the check. Oh, okay, I see. You moved the check that would add, that would increment in the thing, and then the other statement.
Yes.
Google Docs is just being a little bit annoying here. But okay, and so this means that you can reduce the space complexity to be what?
To the order of length of small string.
Right. And this is helpful because, like, imagine if we go, I'm at the example right now. Imagine a string where it's like, you've got like, you know, tons of characters that are not in the small string. You'd rather not store them.
Yes, correct. I don't need to store them at all. Why waste space for that in my map?
Yeah, exactly.
Yeah.
And so could you, because we've got about 5 minutes left, could you walk me through any improvements that you could make from a code point of view, from a syntactic point of view, to your function here?
Just to check, 5 minutes left to 45 minutes?
Yeah.
Oh, okay, that was fast. Okay. Yeah, one thing I could have done is that there is some redundant code, which is basically addition, right? So instead of making it like separately for the first window and for then for sliding, maybe I could have made it like single code, and I could have like a single for loop where I is less than or equal to n minus l, and I could have done this removing part only if my I is greater than or equal to l. Does that make sense?
Okay.
Yeah. So that was one way. Now that is a trade-off. Like some might prefer writing it like this, that I'm filling my window and then sliding it so it is separate code, while some might prefer to keep it in one place. So that is a trade-off, and that is dependent on how one writes the code. Then then certain naming conventions, like I've used L for the length and I for my for loop, so that could have changed. Does that sound good?
Yeah. Anything else?
Maybe when I am passing no, actually that's it, I guess. Is there anything from your side that I could have improved?
On my side, just I think like in this part of the code, which is a little bit hard to read now because of the Google Docs stuff, but I think that like you probably the main thing that strikes me is just grabbing the, like, I would have probably captured the variables like something along the lines of, and correct me if this is, I don't know if this is right, C++, but string left car equals big string of I, and then string, or is it car? Is the type car in C++?
Yeah, car is there, yes.
Car. Okay, something like this. I think this would, since you use like big string of I plus L so many times, like 3 times, yeah, I think this could have helped, at least from a readability perspective. It's not like you're doing, this is not like an extra time operation, just from a readability perspective.
Yeah. True, actually readability improves a lot, but again, some people would say that you are taking up 2 extra characters and they ending up taking more space. But yeah, it increases the readability a lot. Yeah, true.
Okay, well, listen, Kirti, I think we can end it here because we've got just like 2 minutes. So let's jump into some feedback.
Sure.
Okay, so I'm going to stop the timer. So first of all, how did you feel about this?
I have done only one question, so I'm not very sure. But I think we did cover all the cases, and we did cover all the scenarios to be handled. So I think the discussion was healthy and it was good. But I'm not sure if you're expecting me to do one more question in 45 minutes.
But so, okay, so to answer your feedback, I think, first of all, it's important. I think you have to get out of your mind, because I noticed that you told me this when we did the other interview as well, that you have to go through 2 questions in an interview. I don't know who told you this, or if it's just like a convention or something, but like that's not actually, there isn't an actual rule about that. Certainly not at Google or at Facebook when they interview you. Yes, some questions or some interviews, they might start with an easier question and work your way up to a second one. But like for this particular question, I would have been impressed, very impressed, if you had gone through it all in time to have an entire other question. But I consider this question a very hard one, both like algorithmically, but also to then code out. Like you saw that it takes time, right? It's not something you can do just in like 10 minutes. So I would not worry about not going through more than one question. And I would really not let that affect you, especially as you're going through the interview. If you're starting to stress that you're like, oh, I'm not going to have time for a second question, like odds are the interviewer didn't think you were going to go through a second question. And here I did not think you were going to go through a second one. So that's number one. So then as far as how you did, so let's look, we have this feedback form here on Algoexpert that's very similar to the Google one, with the 4 main things being algorithms, coding, communication, problem solving, a few other things like whether you thrive under ambiguity and things like that, but these are the main 4 ones. So for algorithms, I think I would put, for this question, somewhere between a 3 and a 4. I think that this is probably, I think, a 3 for this question. You clearly like immediately realized that you could probably use a sliding window to solve this. You didn't even consider the fact that you could have gone through every single permutation and all that, which would be an obscene time complexity. So you clearly got the optimal algorithmic complexity there. You also were immediately trying to optimize things like the not going through the maps every time and everything. I did give you that one hint about can you do you have to go through the maps even in those like edge cases? And I think that kind of triggered you to realize like, oh, I can just keep track of the counter. But like overall, it didn't seem like you were super stuck there. And then also, same thing for the space complexity. I gave you that little nudge with do you have to keep track of the big string characters? But like overall, I don't think that was particularly bad. It didn't seem like you were completely off mark. So yeah, I think I would give you a 3 for algorithms. And for those who've watched the other mock interview that we did where I gave you like a 4 immediately, you might remember, Kirti, in that one, I felt like that one, it's like both questions that we did, you kind of like, you had like everything kind of optimal without my even needing to kind of like ask questions or things like that. That's not to say that this was bad, right? I think this was still like very good. A 3, candidate was able to come up with an optimal algorithm, blah, blah. Then we'll go to problem solving just because it's related. Problem solving, I think I would put a 4 because you approached the problem like very soundly. You asked a few clarifying questions at the beginning where there wasn't that much to clarify about the problem, but you did ask what needed to be clarified. You clearly, you went through the first sliding window, like the first for loop. Then you went through the rest of the logic. You went back to the example. You did the like off by 1 error with the 1 plus L minus 1, and you like walked through that. Overall, yeah, I think the problem solving was good, and there was nothing there that I saw that it could be like glaringly improved. Then let's go with communication. I think communication was, I would probably put a 3 for the communication. I think you communicated well. The main reason that I like wouldn't put a 4 would just be because like maybe like there were a few times in the interview where I was like a tiny bit confused, like I wasn't following entirely, and I always try to make sure like is it my fault? Am I dozing off, or is it because you could have communicated a little bit better? I think it might have been like somewhere in between, and this is where I think the readability in the code could have helped there. Like sometimes the readability in the code can be really helpful just to help your interviewer follow along. But overall, still like communication was still good, and I think the only places to improve would maybe be just overly communicating and overly making sure that, like as an example, especially when you're on a Google Doc and you're on a video call, right? Sometimes you'll say things like, so here, you see the letter that I have, and I'm like, wait, where? Because I was scrolled down and I didn't see that you went back up to the example. So just like you could be like, by the way, going back up to the example, I'm at the top. Do you see my cursor? And these kinds of things.
Okay, makes sense.
And by the way, yeah, and just these like it's almost like these are little hacks that are. It's not even that this would help, that this would make me think, oh, she's a better communicator, but it's more that like it will help me not get lost, and that will further give the impression that yes, you did communicate very well.
True. I agree. I completely agree. But I guess communication was better than the last interview, I hope.
Yeah, I think it was a little bit better than the last interview. But remember, the last interview wasn't bad either. I think, but I forget if in the last interview I was hovering. I almost said 2, although 2 is a bit too harsh. Like if you look at the text for 2, it's a little bit too harsh. But here I would put communication somewhere between a 3 and a 4. If I had to pick between the two, I'd probably go 3. But
okay.
Yeah,
I get it.
And then for code, I would probably end up going with a 3 again. Maybe leaning between. It's always hard, like, and maybe I would have to re-review your code. Between 2 and 3, or maybe a little bit between 3 and 4. The main thing with the code again, and here I understand that some people also have, like, this is a tiny bit subjective. I tend to favor readability and descriptive names a lot. I understand though that like, and this I think is very important, and you do it well. I think you could even do it a little bit more fervently. You always say like, I'm naming this counter CTR just for speed in the interview and in the Google Docs, but I would otherwise name it, properly. I think that is good because at least it tells your interviewer that you are thinking about that. But the main thing was like maybe capturing those like left characters, right characters. I think that could have been an obvious improvement. Although you seem to say that like you feel like you've maybe encountered people who wouldn't have liked that. I'm not sure there, but
especially when preparing for interviews, like we saw a lot of questions on lead code, right? And actually, this is a good point to say to our viewers, because in lead code, if you see, people are really, really fan of like solutions which are in like, say, 4 lines instead of the ones in 10 lines.
But those are like that's bad. Like I don't want to shoot. I don't want to shots fired. But that's just bad. Like that's bad, and that's how you end up getting like 2s, if not 1s, in coding. Which is why like doing bad practice where you get into the habit of doing that is not good. And you said it yourself that in your experience with other interviews, like real interviews, you've seen that sometimes the interviewer will like focus a lot on just like the code, and even if the algorithmic problem is actually kind of simple. So yeah.
That is actually a good point to be discussed. That's nice. Yeah.
And always remember that what is really good in competitive programming, because you're optimizing for literally like speed of typing and everything, is not good in a coding interview and in a production code base.
This is why
for the
not
most
all
part,
competitive programmers end up cracking like big companies like Google. Not all competitive programmers are able to do.
Right. Because again, like if you write a function that's like only DFS, DP, CTR and L, and you don't even tell your interviewer what those stand for or what they represent, like you might even completely lose the interviewer. And it doesn't necessarily mean that the interviewer is bad. It could just mean that humans need to. There's a reason that like readability and maintainability are like important concepts, But so that's that. And again, the last thing I'll re-hammer here is just at the very least, if you do go for speed in your interviews or whatever, be vocal about it. I think here you could have been even more vocal with me. I don't think you need to ask me. You don't need to ask me like, do you like this name or should I name it better? You can just tell me like, here in the interest of speed, I'd like to name this counter, or even not counter. You named it CTR, right? I'd like to name it CTR. In a production code base, I would name it something more descriptive. Would you like me to have to type it out entirely for the interview, or can I opt for speed here, just in the name of speed? And that way, you've completely told your interviewer, like, I know how to name things. I know how to make things not confusing, blah, blah, blah. Does that make sense?
Yeah, makes sense.
Okay.
So
okay, cool.
Overall, leaning higher, strong, higher, what do you think?
So overall, strong, no higher. No, I'm joking. Not at all, no. I think this would be somewhere between a higher and a leaning higher, I think.
Okay. Not a strong higher. Okay, I need to improve.
I think a strong higher, you saw that in the previous interview, I gave you a strong higher, because I think in the previous interview there were, like, by the way, remember this is always like kind of an art, not a science. It's not necessarily that like, the exact scores map to something. But in the previous interview, if I remember correctly, I ended up going with like 2 4s versus only 1 4. And here, like strong higher, basically, I think we even say it here, you would fight to get this candidate hired. Like in the previous interview, coming out of that previous interview, I would have fought to get you hired. Like if I had been on the hiring committee, although I wouldn't be as an interviewer, but I would have said like really, she performed super well in this interview. I really think that if she didn't perform well in another interview, dig into that one because she really did perform super well in this one, and I think it's important to know that. Here, I think you did very well. Like I'm not this is in no world would I give you personally a leaning no higher, and certainly not strong no higher or no higher. But it's not quite as strong higher. So I would give you a higher or a leaning higher, and those are still 2 very good scores, and you would very likely, if you perform the same way across all interviews, you would especially with the one that we did before, you would likely get a higher decision from the hiring committee.
Sounds good. Yeah. So I guess we are done. Any last words, Clement, for our viewers? How was your experience interviewing me?
That's it, though. This was really fun. I mean, I think you should be really proud. Kirti, you're going through tons of interviews right now. You've been doing a lot of prep. I know you also have a full-time job, and you should just be happy. You performed super well in these 2 interviews that are also stressful, timed. And if you take the average of the 2 interviews where you effectively covered 3 questions, 2 of which I deem to be very hard on Algoexpert, this one and the one with the apartments and the other one, and the last one and the other one hard. You did very well on all of them. So your average score is somewhere between the higher and strong higher. So
that means so much. Thank you.